Hello coders, welcome to my channel Coding Ho Jaye. Today we are going to solve most interesting problem, majority element. This is today POTD of GFG. Let's go. What is the problem actually said? Given an array, find the majority element in the array. If no majority element exists, return minus one. Note: a majority element is an array is an element that appears strictly more than array size and half times in the array. Uh, so basically we have a given an array and said find majority element, and majority element is that number of such element which is strictly greater than the half of the array size. Let's take an example. We have a given 1 1 2 1 3 5 1. Just showing in the example number first. uh, when you go through the an example, in the first example of a given an array, we can see the first element, which is 1, is the count. We can count 1 2 3 and 4 here for 1 in the array. So we can see that is the it is basic, the size of the array is 7. It is 1 is the strictly greater than the array of size. That's why I the output is the 1. In this video, I explain uh, two methods which solve the majority element, and next video I explain the optimized method for the majority, how to find the majority element. First approach is the brute force approach. First approach is the brute force approach. We can use two for loop, brute force approach. Let's see how to solve this problem using brute force method. First, I take a for loop which is start from I starting index 0 and I less than array dot size in I increasing order. Next, and take a variable which is show the count of the element. Next, take another variable which is start from ith index and end array dot size. And if array of I, which means first element is the array of I, is equal to array of j, then count plus plus. Here we can see that first element is the 1 and j is starting from the first index. So here, and j is strictly iterated one by one, and whenever array of I equal to array of j, then count plus plus, which means count increase. First start from first index and j start from also first index. So here we can see that first index is 1 and next first index of j is 1. So both are equal, then count is 1. Next, j iterate 1, and we can see that 1 is the next element is also 1. That's why count is plus plus. Also iterate in each element in the nth element. After that, we check if count greater than array dot size by 2, which means half of the array size, then return array of I. If we didn't find the strictly majority element, then we print return -1. So compile and run this code. We can see first a test case is passed and submit that code. Here test case pass only 1110, and rest of the test case is the time limit exceed. So this is the brute force approach. So that's why we can solve we can't solve the optimize we can solve the optimize using optimize method. And this code time complexity is O of O n square, and space complexity is O of 1. Next approach we are solve using the map. Let's take an ordered map. Just we are using map. Just count the frequency of each element which is present in the array. Start from int num, which is denoted to each element of the array, and we push all the elements in the map and count the frequency of the element, and after that we check the frequency. If our count, sorry, nums greater than array dot size half, then return array of return num. After that return -1. If if we didn't got the element, then return the -1. Compile and run. First test case is passed. Next. Oh, here we can see that all the test cases passed for this example, and in this code time complexity is of n and space complexity is of n. But we can see the actual expected given expected time complexities in this problem is O of n, and the space complexities of 1. So in this video I explain only two method. In the next video we can use the optimize method of this problem that solve the O of n squared sorry, O of n time complexity and the space complexities of 1. Thank you. Please subscribe my channel.